Hi, I'm Annalou, and in today's lesson we're going to be looking at prime factors. The learning objective set by Edexcel for this is we need to be able to break down numbers into prime factors. There are a few keywords that we need for today's lesson: factor, multiple and prime, so let's look at those now. Factors are whole numbers that a number will divide by, leaving a whole number as a result. So factors of 12 are 1, 2, 3, 4, 6 and 12. Because if you think of the different ways we can make 12, 1 times 12 equals 12, 2 times 6 equals 12, and 3 times 4 equals 12. So that gives us the factors of 12 as 1, 2, 3, 4, 6 and 12. Because these are all numbers that will times together to get 12, and all numbers that 12 can be divided by to leave a whole number as a result. Multiples are numbers that are one whole number multiplied by another. So examples, multiples of 12 will be 12, 24, 36, 48, etc, etc, etc. So multiples are basically the times table of that number. Prime numbers are numbers that can only be divided by themselves and 1. So a prime number only has two factors, itself and 1. So 3 is a prime number as it can only be divided by 3 and 1. 12 is not, as we've already seen. 12 can divide by 1, 2, 3, 4, 6 and 12. Another prime number will be 7. 7 can only be divided by 1 and 7. Two is the first prime number and is the only even prime number. 1 is not a prime number because remember, a prime number has two factors, itself and 1. So 2, 3, 5, 7 and 11 are the first 5 prime numbers. As you can see, 2 is the only even prime number because all other even numbers will divide by 2. So 4, for example, can be 1 times 4 or 2 times 2. So 4 has 3 factors, 1, 2 and 4. You've noticed they're mainly odd numbers. Not all odd numbers are prime numbers because 9, for example, can be 1 times 9 and 3 times 3. So therefore the factors of 9 are 1, 3 and 9. So because that has 3 factors, that's not a prime number. So a prime number only has 2 factors, itself and 1. Any number can be expressed as a product of prime factors. So to express a number in this format, how we do this is we divide it by the first possible prime number it'll divide by, and then take the result and repeat this process until we have all the prime number factors. A factor tree is usually used to do prime factor decomposition. So let's have a look at some examples. 72. Now the first prime number that 72 will divide by is 2. So if I divide 72 by 2, I get 36 as my result. I always recommend circling your prime numbers as you go so that you know when you're collecting them again at the end. So 36. 36, again, 2 is my lowest prime number and 36 does divide by 2. And if I divide 36 by 2, I get 18. 18 divides by 2 as well, and I get 9. 9 does not divide by 2 to give a whole number as an answer, but it does divide by 3, which is a prime factor, and that gives me 3 and 3. So I can see the prime numbers that I need to multiply together to get 72 would be 2 times 2 times 2 times 3 times 3. This is expressing a number as a product of prime factors. When I'm expressing it as a product of prime factors, I need to make sure I remember to write equals 72 at the end. So I need to remember to finish that sum. It can also be expressed in index form. So index form is when we use a component to show how many times that number has been multiplied by itself. So 2 times 2 times 2 is the same as saying 2 to the power of 3. And 3 times 3 is the same as saying 3 to the power of 2. So it can also be expressed in index form. Let's have a look at another example. Let's look at 90. So 90, again, it does divide by 2, leaving me with 45 as the result. 45 does not divide by 2 and give a whole number as an answer. So let's divide it by 3 instead. Now we're left with 15, which again would be divided by 3, which gives me 5. Now I'm left with all the prime numbers. So my prime factors of 90 would be 2 times 3 times 3 times 5. Or in index form, 2 times 3 squared, or 3 to the power of 2, times by 5, because 3 times 3 can be expressed as 3 to the power of 2. Let's have a look at an exam style question. So write 140 as a product of its prime factors. Now 140 will divide by 2, leaving me with 70. It'll then divide by 2 again, leaving me with 35. 35 does not divide by 2, but it does divide by 5 and leave me with 7, which is a prime number. So writing 140 as a product of its prime factors, I've got 2 times 2 times 5 times 7 equals 140. Or in index notation, that can be written as 2 squared times 5 times 7 equals 140. Let's have a look at the last 2 exam style questions. If you want to pause and have a go at these yourself, we'll look at the answers together. So if I was dealing with this question, I need to divide 60 into a product of its prime factors. Now 60 does divide by 2, which is my first prime number, so I'm going to circle that because it's a prime. 2 times 30 equals 60. So now on my 30 divides by 2 and gives me 15. So again, I'm going to circle my prime number. 15 does not divide by 2, but it does divide by 3 and give me 5. So now that I've got all my prime numbers, I need to express it. So writing 60 as a product of prime factors would be 2 times 2 times 3 times 5 equals 60. It's good practice to write these in order. So 2 times 3 times 2 times 5 is not as good as 2 times 2 times 3 times 5. It's very good practice to make sure these are in the correct order. It can also be written in index notation because 2 times 2 is also equal to 2 squared. So 2 squared times 3 times 5 equals 60. And my last example, 96. So 96 does divide by 2, giving me 48. 48 again divides by 2, giving me 24. 24 divides by 2, giving me 12. 12 divides by 2, giving me 6. And 6 divides by 2, giving me 3. So now I've got all my prime numbers circled. I can write them out properly. So as a product of prime factors, 96 is 2 times 2 times 2 times 2 times 2 times 3 equals 96. Or in index notation, I've got 5 2's there. So I would be 2 to the power of 5 times by 3 equals 96. And that is how I express a number as a product of prime factors. So thank you for watching. I hope you enjoyed today's video.